Hello guys and welcome back. So now in this video what we're gonna do, we will add the camera collision. So for example, if the player is standing right here and the camera, for now as you can see, it goes inside the container, okay, as you can see. So we actually don't want this collision, okay. We want that when the camera moves to right here, then we want the camera to collide with this container, and we want to move the camera closer to the player, okay, and not we don't want the camera to not go inside the container like this, okay. And also after collision, if then the player start moving, we also want the camera to move to back to its default position like this, okay. So for this, what we're gonna do, we will create a new header right here by the name of camera collision, and in here we will create a public float by the name of camera collision offset. By default this will be 0.2. Then we will create another float by the name of minimum collision offset. We will set it to 0.2, and then after this we will create another float by the name of camera collision radius, and it will be 2, okay. And also at the top we need a reference to the layer mask, okay. So what this layer mask will do, let me first of all name this as collision layer, okay. So on the collision layer we gonna add all of the environment, okay. So all of the environment is for now set to default layer, okay. So when we assign default layer on this one, then whatever that is on the default layer, the camera will collide with it, okay. And also we need to create a float by the name of default position, okay. This will be the default position of the camera. Now in the awake method, first of all what we're gonna do, we will set the default position so it will be equals to the camera current position. So actually we need another reference as well for this. Right here at the top, let's create a public transform by the name camera transform, okay. And then before setting the default position, let's set the camera transform. So it will be equals to camera dot main dot transform, okay. So what this will do, this will basically get the main camera current transform, okay. And now right here we're gonna say camera transform dot local position dot z. That is it, okay. So once we set these two up, after this scroll down to the bottom, let's create a new method by the name of handle camera, or actually let's just name this as camera collision, okay. And let's call this camera collision in this handle all camera movement method, okay. Now in the camera collision, what we're gonna do first of all is we will create a float by the name of target position, okay. And this target position will be equals to the camera default position, okay. And also what we're gonna do is we're gonna take this vector 3 rotation, so just copy it from there, remove vector 3, then okay, and paste it at the top like that. And also let's take this quaternion target rotation, copy it, paste it up there, and remove quaternion from there. Okay, because in the previous video I forgot to do this. Okay, like this it looks more clean. Okay, nothing else. So now once you do this, right here, now we're gonna create a raycast hit type variable hit, because in this we're gonna store whatever the camera hit. Okay, because by using a raycast we're gonna detect objects. Okay, so now let's create a vector 3 by the name of direction, and let's get the camera transform dot position minus camera pivot dot position. Okay, then we're gonna say direction dot normalize in order to make this, as the name suggests, normalize. Okay, now we're gonna now create a sphere around the camera pivot game object. Okay, in order to detect anything, and when it detect anything, then we're gonna know that there is something, and then we will collide the camera with it. Okay, so we are actually not using raycast. We will just use a sphere. Okay, we will create a sphere around the camera pivot game object, and then it will detect anything. Okay, so what we will do, we will say physics dot sphere. Okay, let me first of all show you how this will work. So we're gonna create a sphere around the camera like this. Okay, and then if this camera is moving in the environment anywhere, okay, and for example if we have the container right here, so then if the camera moves to this container, then we will be having a sphere right here. So if this sphere collide with it, then it will know that there is something closer to the camera, so the camera will not go inside the container. Okay, so it will work similar as what I have explained. So now we will say physics dot sphere cast. Okay, we're gonna create that, as I told you, around the camera pivot dot transform dot position, and then we will pass the camera collision radius. So to create a radius, or you can say to give radius to that sphere, and then we're gonna give it a direction. So the direction will be this direction from the camera position minus the pivot position. Okay, then whatever it hits will be stored inside this hit, and then we're gonna say mathf dot abs to get the absolute of the target position, and then at the end we're gonna pass the collision layer. Okay, and let's add all of this inside an if condition. So now if we are creating a sphere, okay, then now create a float by the name of distance. This will be equals to vector 3 dot distance. Let's pass camera pivot dot position, then we will say hit dot point. Okay, and then we will say target position equals to minus distance minus camera collision offset. Alright, so what this will do, this will basically, when we create a sphere, then if that sphere hits anything, then what we're gonna do, we will move the camera a little bit away from that collision point. Okay, and that is the reason we created this camera collision offset. Okay, so it will give a little bit of set so that the camera don't go that much inside that game object. Okay, now we will say right here mathf dot absolute target position if that is less than the minimum collision offset. Okay, then what we're gonna do, we will set the target position to the target position minus minimum collision offset. Okay, then at the end we will say camera vector position. Let me actually declare this at the top. Okay, so private vector 3 camera vector position. Then if we scroll down right here, camera vector position dot c equals to mathf dot lerp, then camera transform dot local position dot z, then we will set target position and then 0.2f. Then after this we will say camera transform dot local position will be now equals to the camera vector position. Okay, so right here we are just basically changing the one position, the z position. Okay, and this med dot lerp means that we are lerping between the camera transform dot local position dot z and the target position, and at the end this is just a time, so we just pass 0.2f. Okay, so this is, I think, it for the camera collision. We now save this. Okay, and right here I need to type S physics. All right, now if you click on camera manager, here it is. We need to provide the collision layer. So first of all, let's add a layer to our player. So I click on layer. Right here I will just remove this camera one. I will just simply type player. Okay, click on player and add that. Yes, change children. And also if you check the whole environment, they are set on the default layer, as you can see. So what we're gonna do now, if you click on camera manager right here, select player and default so that it collides with these two. Okay, so once you add the collision layers, default and player, okay, as you know that the camera manager is also on the default layer, so make sure that you change it to a camera layer. Click on yes, change children. If you don't add a camera layer, then just simply click on add layer, type camera, click on camera manager and attach the camera layer. Okay, because we want the camera to be on a separate layer. Okay, now the collision layer will be default and player, and also make sure that your camera collision radius is a lower value, for example 0.2, or you can say 0.2. You can also change it right here in the script as well. So camera collision radius should be 0.2. Okay, now after these changes, if we now play the game, okay, so here is the player. Now if we get closer to this container again, okay, here it is. Now if we try to collide the camera, now as you can see the camera is moving closer to the player, and after when the camera is done colliding, we are back again in our own default position. And as you can see, when it collides, the camera moves, or you can say the camera zoom in on the player. As you can see, if we move it down here, as you can see there is this box down below, so if we try to collide with it, as you can see it moves closer to the player, and if we do it from this side, it also moves closer to the player. Okay, As you can see now, we have this collision. Okay, the camera is not going inside the container. Okay, you can also change these values. Okay, but 0.2, 0.2, 0.2 are the perfect values. As you can see, one should be a good value as well. If you want to leave it as 1, you can do that as well. But when you make it 1, as you can see, it is not that much zoomed in. Okay, but anyways, it depends on your own liking. You can change that values to 1 if you want, or you can mess around with it and do it as your own liking, but make sure that your camera collision radius is 0.2. Okay, so that the camera zoom in on the player instead of going inside the object. So now we have the camera collision as well, and with this done, let's end this video right here.